Good morning to the grade 8s. This is your chapter 10 practice sheet for solving algebraic equations using opposite operations. So far, we've solved equations using inspection. We've solved equations using modeling. And now the third and final step we're going to learn is solving it using opposite operations. And for some of you, you don't have a great deal of experience. So after we get through the true-false, what I'm going to hold you all accountable for is the exact same work that I have done on the board is what you must write exactly as I do it. So if you're not doing it and there's something you're doing differently, even if it's putting a multiplication sign instead of brackets, you need to make a note of it because for assessment purposes, I need to make sure that we all are using the same type of method for solving these equations. So the first question, it says the opposite of dividing by 2 is multiplying by 2. 25% of you thought that was true. So if I had this equation, and this would be multiplying by -2 right here. This is what that coefficient of -2 is. If I was to solve it using the opposite operation, the opposite of that is not dividing by 2. It would be dividing by whatever the coefficient is, in this case, -2. So the answer for this is false. And you must say the opposite of dividing by -2 is multiplying by -2. Okay? The same way that if you had this question, the opposite of dividing by -2 would be multiplying by -2 because they are opposite operations. So the point I wanted you to get across is that the opposite of adding 2, so if I had, let me just pause for a second. If I had the equation x plus 2 equals 3. Now the opposite of adding 2 is subtracting 2. Okay, it's not subtracting a -2, or it's the opposite operation. The opposite of addition is subtraction. So the opposite of adding 2 is subtracting 2. The opposite of multiplying by -2 is dividing by -2. And that's the tricky part for some people to get across is they think they have to divide by the opposite number 2. So if it's a -2 coefficient, they think they have to multiply or divide, by a +2, but that's not true. Whatever your coefficient is, you always have to multiply or divide by that number, even if it's negative. The second question in the equation, -14 is equal to -2 plus 3x. The first thing that should be done or applied to both sides is to add 14 to both sides, and the answer is false. And the reason why this question is written is because in most of your experience so far, you've had something that looks like this. 2x plus 1 equals 3. You've had a coefficient, a variable, a constant, and then a value. And you've always taken whatever that plus minus value is, and you've done the same thing to both sides to get rid of it. In this equation, that plus or minus value looks to be the -14, but it's not, because you have to identify the constant. The thing you want to get rid of first in two-step equations is the constant, and the constant in this equation is -2. So what you would do is you would add 2 to both sides. Now, if you're having difficulty seeing what the constant is, what I recommend you do is think of it as a model. There's -14, there's -2, and there's 3x. And keep in mind your constant is the plus or minus integer chip value on the side of the variable. So the plus or minus value that is on the side of the variable is called your constant. And in an algebraic equation, your goal is to get rid of everything and isolate the variable. Your coefficient is really how many of the variable you have, right? In this case, you have 3 x's, so 3 is your coefficient and -2 is your constant, right? So you must keep that in mind. And -14 over here, because there are no variables with it, is not a constant, it's the equivalent value. And our goal is to use that to figure out how much each of the x's are valued at or worth. Okay. Question 3, in equations with more than one step, you should always eliminate the constant first by applying opposite operations. And the answer for that is, of course, true, just like we just talked about. So in a grade 7 question, the opposite of adding 1 is subtracting 1, and by doing so, I get rid of the constant. In a different question like -3 plus x equals 4, your constant is that -3. And again, for those people who are having difficulty understanding why, if I put -3 and an x and a 4, that constant is this on the side of the variable, and it's the plus minus value or the integer chip value that is with the variable. So that would be our constant. So here I would add 3, which is the opposite operation to get rid of it, and I'd have x equals 7. In our fourth question, it says in the equation 4 minus x over 2, or 4 minus half of x is equal to -3. The second thing I would do to both sides is to multiply both sides by -2. Now this is a really tricky question, and I'll tell you why. Because when I write this out, the first thing I'm going to do is I know this is a positive 4, right? If I was drawing it, I would have 4 positives here, and I'd have this negative half, this negative half, it's negative half, not a positive half, equals -3. The first thing I would do is get rid of this positive 4, and I would do so by subtracting 4 from both sides. Now, here's where it gets complicated. Once I do that, the question I want to ask you is, over here, I have -7. But what's left? Okay. Now, technically, this subtraction sign does not disappear. So technically, this is what your question is, a negative half of x. Okay. But what I want you to keep in mind, and this is really important, I'm going to erase this part up here. This is probably the most important part of this whole exercise, is that this idea is the same thing as, if I read it's going to be a negative half of x. It's a negative half of x. And when I think of that as being a negative half of x, I could write it 2 different ways. If I think about integer sign rules, if I think of the negative half of x as either being negative x over 2, which is still going to be, because a positive divided by negative is a negative, or a negative divided by a positive is still a negative. So both of these, and I'll use my highlighter here, this and this, and this, and this are the same thing. So all 4 of those highlighted expressions are all the same thing. And if I go back to the original question of 4 minus a half of x equals -3, so the first thing I did was get rid of my constant by subtracting 4. Once I look at that and I say, well, what's left on that side of the variable? And I see that it's this right here. Right, that's what's left over there. You can see it right now after I get rid of the constant. What your job is to do is to determine what's the best way for me to rewrite that. And you could write it any of these 3 ways. Obviously, you're not going to write it as a sentence. And if you acknowledge that that's the way I'm used to seeing it, where my denominator or my bottom term is the plus minus value, the negative coefficient, then when you take this, what you're going to do is you're going to write it as x over -2 is equal to -7. So you simply take your negative sign and put it there, right? Or your subtraction sign, or you consider it a negative sign or a subtraction sign, and you put it in with your denominator. And the reason why you do that is because now, look, now I can multiply both sides by -2, and I get my x value as positive 14, right? Does that make sense to people? So when you get to this and you get rid of your constant and you're left with this, don't ignore the subtraction sign. It's a part of your term. Put it with the denominator because it's going to make your isolating the variable right here a lot easier. By the way, so the answer was true. The answer was true. Question 5 is exactly what we just talked about, right? So a negative half of x is the same thing as a negative half of x, which is the same thing as a negative half of x. This is true. And I guess the easiest way for us to see this is to put a value for x. And we're going to make x equal to 4. So I'm going to tell everybody that x is actually 4, okay? And what I'm going to do is I'm going to change each of these x's to 4. And I'm going to ask you to consider what the value of each of these three expressions would be. Here, negative 4 divided by 2 is going to be a negative 2 because a negative 4 divided by 2, 4 divided by 2 is 2, negative divided by positive is negative. Here, a negative 4 divided by 2, well, 4 divided by 2 is 2, so a negative value of that would be negative 2. And here, a 4 divided by a negative 2 is going to be a negative 2. So in every one of those expressions, I can see that they're equal by just substituting a value for x and asking what is the expression's value, and they're all the same. So therefore, all three of these ways of writing it are all equal to a negative half of x. They are all expressing the same thing, a negative half of an x value, whatever that x value is. Question 6 is the hardest question, maybe. And what it's asking you to do is, if I gave you this, how do you read that? Okay, how would I read that expression? And the answer is, well, how would you read this one? And you would say, this is 2x, right? Agreed? How would I read this one? Well, since this was the coefficient, I said 2. This is the coefficient, and we've never seen a decimal coefficient before, because in grade 7 you never use decimal coefficients, but they exist. And since 0.5 is a half, I would read this as half x. And then if I say, well, what's this one? Well, we're used to this one because we've seen this one. And how do we read this one? We read this one as half x, and we can see it best by drawing it, or x divided by 2. Half of x would be x divided by 2. So therefore, they are the same thing, because this is half x, and this is half x. Now there is another way to do it. Does anyone know what the other way is? Instead of doing 0.5x, what else could I do? I could use a fraction instead, so I could actually write a half x, right? A half of x. Coefficients are multiplication, so when I say half of, we all know that of means multiplication. So this would be half of x, this would be half of x, and this is half of x. Question number 7 says, in the equation negative 2x equals negative 10, the value of x will be negative. Well, the only way to really do that is to ask yourself, a negative multiplied by what? A negative multiplied by what is a negative? A negative multiplied by what is a negative? Is that going to be a positive value or a negative value? Using integer laws. Negative times what is negative? Positive. So this has to be positive, agreed? In order for it to be a negative times something to give you a negative, whatever the x value is, it has to be positive. I don't even care what it is. I can answer the thing and say false. It is going to be positive based on simply sign laws. But what's another way we could do it? Is simply isolate the variable by dividing both sides by negative 2. And x will be equal to a positive 5, because a negative divided by negative is a positive. So there's two ways to do it. There's just simply think about sign laws, right? That has to be a positive value because a negative times a positive is a negative. Or you can actually isolate the variable. And your final true-false question says, in the equation 2x minus 1 equals 12, the value of x will be less than 1. The value of x will be less than 1. Well, let's just think about it. Without isolating it, if I was to just simply cover up, you know what, I'm going to marvel at technology here. Watch this. I'm going to take a creative pen. I'm going to take one of these things here. I'm going to take it, and I'm going to make it bigger, and I'm going to put this over here. And I want you to think about this for a second. What is the value of the smiley face, Aiden? If I say, what is the smiley face's value? If the smiley face take away 1 is 12. The answer for everyone is 13. So that smiley face has to be 13, which means, if I continue with my little experiment here, 2x has to be worth 13. Agreed? So what number multiplied by 2 is 13? The answer would be 6.5, correct? So is x less than 1? No. So therefore, the answer is false. Okay, that's my fault. I put it in the remote wrong. But if you look at this though, what else could we have done instead of using that logic? That's one way to solve it. Just think about what does the x value have to be. The other way is I could just isolate the variable. 2x equals 13, divide by 2, divide by 2, x equals 6.5, or 6.5, right? Both ways work. Now we get into questions 9 through 24. Now here's the dealio, yo. You all have to have exactly what I write. Now there's no difference. If you have anything missing, you have to now take your pen and make a note on your sheet what's missing. Okay? Here we go. So question number 1, or 9, because yes, it's actually question 9. It says negative 2x equals 10. Now in order to solve this, you have to know that that says negative 2 multiplied by x. And since this is opposite operation, you need to say, well, what's the opposite of multiplying something by negative 2? The answer is divide both sides by the coefficient of negative 2. So everybody has to have that exactly written like that. And watch this. You also have to have that. Okay? To show that those are opposite operations. That line that I drew is kind of like a zero pair, but it's more like acknowledging that they are opposite operations. Or if you want to use the word canceling operations, you can. Nullifying. X is left, and 10 divided by 2 is 5, but a positive 10 divided by a negative 2 is a negative 5. Everything has to be the same. Question 10. I have a negative 2 plus x equals 10. So you don't have to draw this part that I'm about to do now, but if I was to model it, don't draw this. This is what it would look like. And if you thought about what am I going to do to both sides, well, I'm going to get rid of this, and I'm going to do so by adding 2 to both sides because that creates zero pair. Same thing happens here, and this is what you have to do. You add 2 to both sides, and x will equal 12. Next question, x divided by negative 2. Now the thing is we don't model negative halves of x because they're almost impossible to draw because there is no way for us to really show a negative half. But what we know is since that says x divided by 2, what we're going to do to both sides is the opposite of dividing by negative 2, which is multiplying by negative 2. Now we're not going to show multiply by negative 2 like this. We're not going to do that because a multiply symbol and an x variable look a lot alike. So we're simply use bracket 2, bracket negative 2, and we're going to show that those are opposite operations with a line. X will equal the product of 10 and negative 2, which is negative 20. Okay? Question 12 says 10 is equal to x minus 2. So you want to get rid of the constant, which means, since the constant is on the side of the variable, you're going to add 2 to both sides, and by doing so, you isolated the variable of x. X equals 12. Now, if you want, instead of saying 12 equals x, you could flip it around at the end and say, since 12 equals x, x equals 12, we're used to having the variable equal something instead of something equals the variable. This is up to you. I don't care which way you do it. Either one is fine. Now we get into two-step equations. Now in two-step algebraic equations, when you have both a constant, which is your plus minus value on your variable side, and you have a coefficient, which is how many of the variable you have, the simplest way to isolate the variable is to get rid of the constant first. So the opposite of subtracting 5 is adding 5. Put your line through it. Now pay attention because you all have to rewrite this step. And I've looked at a lot of sheets, and a lot of people do not have that written out. But on your paper, you need to have written out 2x equals 12. And then, underneath that, you need to divide both sides by the coefficient, and x equals 6. Question 14 is exactly like question 13, except you have a negative 2 coefficient. So the first step is still the same. You're going to add 5 to both sides. Negative 2x equals 12. The only difference between questions 13 and 14 is now my coefficient's negative, which means I'm going to divide both sides by negative 2. And x will equal negative 6. Question 15, 2x plus 5 equals 7, comes right out of your grade 7 textbook. Subtract 5 from both sides. You get 2x equals 2, because a positive 7 and a negative 5, or a minus 5 if you want to think of it that way, makes 2. Oh, sugarcoat. Then you're going to divide both sides by the coefficient of 2, and x will equal, not 0, because I think some people probably said 0 there. Yeah, purple people said 0. Any number divided by itself is not 0, it's 1. So x equals 1. Next question is the same. Subtract 5 from both sides to get rid of your constant. Negative 2x equals 2. The only difference is this time you're going to divide both sides by the negative 2 coefficient, and x will equal negative 1. I'm wondering if those purple people thought that 2 divided by negative 2 was negative 0. I wonder. Question 17. X. This is a question right out of your grade 7 textbook as well. You're going to add 5 to both sides. Half of x is equal to 12 is what you would get after you get rid of the coefficient. So you have to show the plus 5. And then multiply by 2 is bracket 2. Bracket 2 to show multiplication with opposite operation. Put the line to show their opposite. X is equal to 24. Same question. The only difference is it's negative 2 coefficient, negative half coefficient, excuse me. So you're going to add 5 to both sides. You're going to get a negative half of x is equal to 12. You don't say x over negative 2 is not what it says, is it? It's what it looks like. What this really is, you don't have to write this arrow, you don't have to write this, but you can make a note of it. Negative half of x. Right? And again, it could be this. It could be this. But we chose to write it like that. Those are all the same thing. Right? So the next thing you do to get rid of the negative half is to multiply both sides by 2. Negative 2, excuse me. And x will equal negative 24. Subtract 5 from both sides. Half of x is equal to the sum of negative 7 and negative 5. If you think of 7 negative integer chips and 5 negative integer chips, there's no 0 pairs, it's just negative 12. Multiply both sides by 2 to get rid of the divide by 2. And x will equal negative 24. And question 20 says x divided by negative 2 plus 5. So I'm going to subtract 5 from both sides. And I get x over negative 2 is remaining equals negative 12. Multiply both sides by negative 2. And x will equal the product of negative 12 and negative 2. 12 times 2 is 24, and negative times a negative is a positive. Next question 21 is 2 plus 5x equals negative 8. So in this equation, you have to know that this part right here is your constant. And this here is your coefficient. So the first thing we're going to do is get rid of the constant, and we're going to do so by subtracting 2 from both sides, because that is a positive 2. Now, for those people who are having a difficult time seeing that as a positive, if I was to draw it, that's 2, and 5x equals negative 8. So remember, the constant is on the side of the equation with the variable that is your plus minus value, or you draw it with integer chips. So I'm going to subtract 2 from both sides. I'm going to erase this here. And the next thing you're going to do is you're going to rewrite this as 5x equals negative 10. Once you have that, you're down to a one-step algebraic equation. Divide both sides by your coefficient, and x will equal negative 2. In question 22, this is your equation. And again, just like the last one, if I was to draw it, it would be a positive 2 and a negative 5x equals negative 8. Right? So again, the coefficient of 2 is not negative 2. It's still positive 2, which means I'm going to subtract 2 from both sides. If I was modeling, I would put a negative 2 on both sides. And I'd be left with negative 5x is equal to negative 10. This negative sign stays with the coefficient. Then I would divide both sides by negative 5, and x would equal a positive 2. Question 23, negative 5 plus a negative half of x. Remember, we're going to call this one a negative half of x. So if I was drawing it, it would be negative 5 plus a negative half of x. I'm going to call this one negative, equals 0. So the first thing I could do is get rid of that negative 5 constant by adding 5 to both sides. Now, here's where it gets tricky. I have plus a half of x. So a negative half of x still stays a negative half of x, and 0 plus 5 is still going to be 5. So essentially, this plus sign does disappear because I'm adding to the expression this particular value. Now I'm going to multiply both sides by negative 2. And x will have the standard form value of negative 10. And finally, your last question is this. Just like the last question, I'm going to add 5 to both sides to get rid of the constant of negative 5. Now here's where it gets reasonably tricky. You have to know, just like in the true-false, that a negative half of x is written as a negative half of x, which is the same thing as this and this. And when this is left over, okay, what you have to acknowledge is that when I rewrite underneath here, I am going to use this to rewrite it. So this is going to become a negative half of x is equal to 5. And then I'm going to multiply both sides by, that's the world's worst, negative 2. Well, it's even worse than the last time. Multiply both sides by negative 2. And x will equal negative 10.